Hey class, this is the second part of chapter 15 problems. This is 42A and 42B. Depending on how long 42A goes, I may have to extend it to a third part and do 42B for the third part. So let's take a look at this. At 800K, the equilibrium constant for I2, this is the equation. Here we go. There we go. Okay. So I got I2 like this, to 2I. That means it's breaking the bond. That forms I2 for Brinkelhoff. The Kc is given to me as 3.1 times 10 to the negative fifth. Excellent. The equilibrium mixture, and it's 10 liters, so I have a volume. The volume is 10 liters. Contains, okay, now, so for the first part of this, we should know that the K equation, the K expression, for this reaction is very simply the concentration of I squared of I, and that whole concentration squared, over concentration of I2, like that. And that all equals then 3.1 times 10 to the negative fifth. So the first thing I need to do is find this right here, concentration of I. And here's how I do that. It's actually pretty simple because the amount of mass that's given to us is 2.67 times 10 to the negative 2. That's the number of grams. That's of I, okay, at equilibrium. And I'm going to simply change that to moles. So when I change that to moles, then I can find the concentration. The reason why I can do that is these brackets here mean molarity. Molarity means moles per volume, or moles per liter. Okay? So I'm going to use that equation, molarity equals moles per volume, to find, and we have volume right here, obviously, to find the concentration of I. So let's do that. So that means that 1 mole of I is equal to 126.9 grams. So that is the atomic mass right here on any periodic table of iodine. And when I take the 2.67, divide that by, and let's take a look at what that says on the calculator. So 2.67 EE to negative equals that divided by 126.9. So it's going to be a pretty small number, and what I get is 2.10 times 10 to the negative fourth, like this, and that's the number of moles. So I'm going to divide this again by my volume, just like here. I have my moles here. I'm going to divide by the volume, and the volume is 10 liters. So I divide by 10 liters like this, and this gives me exactly the same thing, 2.10 times 10 to the negative fifth, and this is my concentration now. So that's what I, right here, that's what that equals. So I'm going to move down and give myself a little bit extra room, because what I'm going to do is fit that new number right into here where my equation is, and then I'm going to solve for I2, the concentration of I2, because it says how many grams of I2 are in the mixture. So I'm going to find the number of grams by finding the concentration first. So let's scroll down a little bit to give myself a little more room. Now that means that if I solve for this right here, I'm going to look like this. It's going to be I2, concentration of that, okay, is going to be equal to my concentration of I to the second power divided by the K value. So let's put that in and figure out what that is. That is 2.1 times 10 to the negative fifth, and that's going to be squared. And then I'm going to divide by 3.1 times 10 to the negative fifth. And whatever that equals, then I'm going to do that right here. I'm going to square the value that I have on top. That gets me 4.42 times 10 to the negative 8th or 9th or something like that. It's pretty, looks like 8th. So here's what I mean. That we'll do this in steps. So if you're working this on the calculator, you can follow along. I get to the -8th there. Let me see, 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8. And then that's divided by 3.1 times 10. Oh, you know what? That's wrong, because I didn't divide by 10 for I didn't divide by this first. I missed that step. So let me do all of this over again. 2.67, this won't take long. 2.67 second minus like that, divided by 126.9 equals that, divided by 10 equals that. Okay, so now I've got the right thing. Now I square that. Oh yeah, that gives me times 10 to the negative, it looks like times 10 to the -9th. 1, 2, 3, 4, I just turned there it goes, times 10 to the -10th. So here we go. Now I divide by 3.1 EE5 minus like that. And then what I get then is 1.42 or 1.43. Let's just carry it out. Since we have it, I get 2.8 like this times 10 to the -5th, and that's my concentration like that. So now I need to find the number of moles. So we're going to do a little bit more calculation, and then we'll go from moles. Once we find the number of moles, then we'll go from moles to number of grams. So that's my concentration of I2. That's what this is, like that. And then what I'm going to do with this number then is, because if I'm looking for the number of moles, that equals concentration times volume, okay, which means that I'm going to use this number here. I'm going to change this to 1.42 times 10. Uh-oh, I'm starting to lose the calibration of the smartboard. And then I'm going to multiply that by 10 liters. Okay? So I multiply that by 10 equals the same thing times 10 to the -4th. Okay? 1.4 times 10. There it goes. Times 10 to the -4th. That gives me the number of moles. Now I simply take that number here. I know I'm drawing this out. So I get 1.428 times 10 to the -4th. All of that, that's the number of moles of I2. Come on. There we go. Times, and now I'm going to multiply by. Now what number of grams of 1 mole of I2? So 1 mole, and now we have twice the amount for I, which means that instead of 126.9, the actual molar, the atomic mass of iodine, I'm going to double that, and that's going to be 253.8 grams. So I simply multiply that number by 253.8, and here's what I get. I get a 0. Oh, come on, are you kidding me? 0.0362. There we go, grams of I2. Excellent. Well, that took forever. Lots of calculations, obviously. I used the concentration, there we go, equation. I used that twice, once for I and then once for I2. So that is confusing. Try and follow along. I tried to write out the equation so that you can see what it looks like. And then I'm going to do a part 3 and cut this.